Hi everyone, it's week 5. Welcome into week 5. You made it past the halfway point in this term. So we've only got 4 weeks left, and of course we have lots of material to cover, but we can get through it. You made it through the first half of the semester, so let's get going. I wanted to share with you one of my pictures that I've taken. This is some yellow, I believe it's lantana, and a Gulf fritillary butterfly. It has landed on the flowers, and I just like to share my hobby with you. So there's a picture for you. Let's get into what's going on this week. And first of all, we'll have a short recap about last week. Last week we covered some genetics of DNA and mutations, which are changes in the base sequence of DNA. Now, mutations can result in no change whatsoever in the organism, or gigantic changes, or even lethal changes. So the organism may die from mutations that occur. Mutations can be small, a single nucleotide change, or changes in chromosome number. We also talked about cancer, and cancer consists of your cells that are dividing out of control. And the reason that the cancer is deadly is because those cancer cells take up necessary nutrients for the rest of the cells in your body. They may crowd out parts of your organs, things like that. So we talked about all those things last week. Along with that comes this week. This week we concentrate on evolution. And I give you a short and sweet definition of evolution. One that you can take with you anywhere. A change in genes in a population over time. So this encompasses microevolution, which are very tiny changes in genes in a population over time, which may change, say, the outward coloration of the individuals in a population, or macroevolution, which includes the production of new species, or speciation is what it's called. So here's a short, sweet definition of evolution, and you've got a couple of chapters to read on evolution, the evidence of evolution in chapter 11, and the processes of evolution in chapter 12, so make sure you read those 2 chapters. I have an example for you of evolution in action. This is an amazing and simple but beautiful experiment that the Harvard Medical School did, and I have a link to it on the PowerPoint. I'll also put a link in the announcements. So what has happened with this experiment is that they took some bacteria, they made a gigantic petri dish, which was feet wide and feet long, filled the petri dish with agar, but also with columns of antibiotics. And you know that antibiotics kill bacteria. So they put different concentrations of antibiotics into the different columns in the petri dish. They started growing bacteria on the outsides of the agar, and the bacteria would grow so far, and then they would hit a higher concentration of antibiotic. And what you see in the video is what happens when those bacteria are stressed out, when the population is stressed out. Those bacteria mutate their own DNA, where they can survive in the presence of that amount of antibiotics. So they start growing into the next column. Then they hit a new concentration, maybe 100 times the normal concentration of antibiotic. They develop mutations, begin growing again. It is an amazing video. And in order for these bacteria to develop antibiotic resistance to 1,000 times the normal concentration, it only takes 11 days. This is an amazing video, an amazing experiment. You can see evolution in action. What did we say evolution was? A change in genes in a population over time. So the antibiotic resistance in these bacteria has changed over time in just 11 days because of the stressor in the environment, which is the antibiotic. So please take just a couple of minutes to watch that video. It is absolutely amazing. Like I said, read your 2 chapters, watch the intro video. For your discussion board this week, you're going to choose an example of natural selection. And I'm going to give you one that I saw in my neighborhood back when I lived in Greenville, South Carolina. I lived across the street from some woods, and one springtime, I noticed baby squirrels running through the treetops and the gigantic oak trees that we had across the street. And all of a sudden, I saw a white squirrel. It was an albino squirrel that had been born that spring. And I could see it wherever it was in the trees, and I went out every day and watched for it. And could watch it just running and jumping all across through the tree limbs in the canopy. And after about 3 weeks, I didn't see that little flash of white anymore. So what exactly happened? Well, that little white squirrel was not camouflaged at all. And we had plenty of hawks and owls in our neighborhood. And I'm sure probably one of those hawks got that little squirrel within the first 3 weeks of his life, because it was not camouflaged. It just stood out amongst the oak trees. All those other little gray squirrels that we had survived perfectly fine, and that's an example of natural selection. The coloration of that albino squirrel did not help it a bit that spring. In fact, it helped to select against that particular squirrel, and it did not survive. The other squirrels that had more camouflage coloration, they did survive. So that's just an example from my life of natural selection. Using this example that you've chosen, you can think of one in your life, or you can look one up. That's perfectly fine. Using this example, explain how natural selection impacts evolution. So how did the elimination of that albino squirrel impact the evolution of the squirrel population? That squirrel was eliminated before it reached reproduction age, and so those albino genes were not passed along into the next generation. Now, say an ice age had happened to come along during those 3 weeks, that squirrel would have been selected for, wouldn't it? Because it would have had camouflage color. And all the little gray squirrels would have been eaten up, because owls and hawks and whatever else, eagles now, could have seen the little squirrels and picked them off and eaten them. So the albino genes were eliminated from the population with the death of that one squirrel, and weren't passed on because there was no reproduction of that squirrel. So that's just an example of how you can do that. In your writing example, you need to choose something called a transitional fossil. Choose one. Tell me the name of it. Okay? You're not just talking about transitional fossils. You're telling me one transitional fossil, and I give you a couple of websites here that you can use to help you find one. And then you're going to explore this transitional fossil a little bit, and you're going to tell me the information that this particular fossil gives us that helps us link different species. That's what the rest of this means. What information does it provide about the different lineages? So a transitional fossil makes a connection between older organisms and newer organisms. It's a transition between the two. So tell me what this transitional fossil tells us about the fossil record and organisms. There are many crazy websites out there. I don't trust Wikipedia. I know that you can go there, and they've got a very extensive list of transitional fossils. But I have no idea if the information is good. So please use a reputable source when you do this assignment. And finally, take the quiz. Don't forget to take the quiz. And I hope you have a good week. I'll put these links for you in the announcement section along with this video. As always, you can contact me through the office hours that I have each week, which are Sunday nights from 6 to 7 p.m. Eastern Time, Or, as always, you can email. Email me, I will answer you. So let me know if you're having any issues, if you're having any trouble. If you have any questions, please, please, please ask me questions. I'm here to answer questions for you. And other than that, have a great week. And I will see you soon.